Good afternoon and good morning and welcome wherever you are in the world listening to our ISSS ISTA webinar on seed development and viability. I welcome you here today as your host and excuse the colleagues from the board of ISSS and ISTA. Nonetheless, I would like to give you some more information as well. First of all, if you have questions, please put them in the question and answer box, which I can see and ask our colleagues who are giving the presentation today, which I would like to introduce. We have a first presentation today of Dr. Duarte Figueiredo, on molecular mechanisms driving seed development in flowering plants, and of Dr. Jose Franzaneto for the use of the Tetrazolium test for estimating seed viability and vigor. So far, our two colleagues, and you may see from the names, we have a Portuguese speaking round, so we could hold this seminar also in Portuguese, but for the easiness, we do it in English for all of you. I just want to let you know a few things which my colleagues asked to show you, and one is the following information from ISSS, and I hope you can see the screen properly. It is on the 14th biannual ISSS conference, which ISSS is pleased to introduce in the upcoming year, 3rd to 7th of July. That is directly after the ISTA meeting next year. And it is on challenges of seed science in a changing world, and it will take place in France at the Faculty of Science and Engineering of Sorbonne University, so a very, very scientifically famous place in Paris, beginning of July next year, and it's the great pleasure of the organizing committee to invite you to this event. I would like also to take the opportunity to invite you to an ISTA event, which is a little bit closer this November, beginning of this November. It's the ISTA Seed Symposium 2022. Normally the symposium is part of the Congress, which was held in Cairo, but we decoupled it this year from the Congress, so it's normally part of the Congress. It's the symposium in Athens in Greece, and the topic of that symposium is quality seed for sustainable agriculture. And you still have time to submit papers until the 1st of August via the ISTA website, seedtest.org. And there's also an application possibility for a funding in our Young at ISTA program, which you can fill out and apply for. Well, I would like to start now, and I would like to ask Duarte to start, and I give you a little bit an overview about his background. He studied cellular biology and biotechnology at the University of Lisbon. And after this, he prepared his PhD at the Instituto de Tecnologia Química y Biología of the new University of Lisbon. I would like to ask now our next presenter, who is Jose Franzaneto. I need to give you the permission with the presentation on use of Tetrazolium test for estimating seed viability and vigor. Jose is an agronomic engineer. He graduated from the Superior Agricultural School Luis de Queiroz Esalqui from the University of Sao Paulo in 1975. I shouldn't say that, you look much younger. He holds a master's degree in seed technology obtained from Mississippi State University and PhD in seed physiology and pathology from the University of Florida, and was a postdoc for molecular biology and seed physiology from this same university. He specialized in the University of Illinois and Mississippi State University, University of Novi Sad in Serbia, and INRA, which is now INRAE in France. And he works as a researcher in the seed science area of Embrapa on soybean in Londrina, Paraná in Brazil, since quite a long time, where he developed several technologies for the production and analysis of soybean seeds. He is member of the ISTA Tetrazolium Committee since 1998 and was president of APROSOJA at the Brazilian Association of Producers of Soybean for 3 years from 1999 to 2001, and president of ABRATES, the Brazilian Association of Seed Technology, from 2011 to 2015. He acts as an associate editor of the Brazilian Seed Journal and editor of the ABRATES newsletter. He has published several scientific papers and book chapters and books on technology, production, and analysis of soybean, sunflower seed, and several other crops. Jose, the stage is yours, I would say. Thank you.
Well, thank you. I would like to have your information if you're seeing my screen now.
We see the screen, but we see the not in presentation mode yet.
And what about now?
Now it's perfect.
Okay, great. Well, so the theme of my presentation is going to be related to a very interesting theme about the Tetrazolium test for estimating seed viability and vigor. I'm talking as well on behalf of my colleague Francisco Krizanovsky. We work for Embrapa Soybean, and I thank ISTA and ISSS for the invitation. The Tetrazolium test has been developed and improved since the early years of the 20th century, when the seed industry started to get organized, either in Europe and in America. Initially, the test was used for determining seed viability with the development of its methodology, but it has also been used to evaluate vigor in several different species. Mainly for grain crops, forage crops, horticultural crops, forest species, ornamental and medicinal species. But I'm going to be focusing here on grain crops, forage crops, and some horticultural crops. It's interesting to mention briefly the history of the test. This is a summary of the summary, because it's a very, very interesting history on the development of the test. But everything, whenever we deal with seeds, we cannot we have to mention in 1869 the establishment of the first seed testing station in Taren, Saxony, in 1869 by Frederick Noe. And later on, at the beginning of the 20th century, we have some progresses, but I'll be skipping directly for some successful attempts. In 1922, Turina, in the former Yugoslavia, she started working with the reduction of some salts of tellurium and selenium for observing the seed cells. Later on in 1925, Nelyubov from Russia, he did some studies on using viral stains, such as indigo, carmine, for the identification on viable and unviable tissues. The viable tissue did not stain when you precondition the seeds under these salts. Hasegawa in Japan in 1935, he did a great development using selenium and tellurium salts. But at that time, he was keeping all the information of the methods for himself, up to a point when he went to Germany, and he did some presentation, and he finally opened up the methodology for Eidman and Schmidt, who later on improved the selenium methods and introduced, interestingly, they introduced the concepts of viability and vigor using terms such as total germinated seeds, weak germinated, and dead seeds, something that was used for the first time. And in the ISTA Congress in Zurich, 1937, Eidman reports the Eidman method for determining seed viability. But later on, Hasegawa mentioned that he did some previous work, and ISTA started to use the Eidman-Hasegawa method to calm down the situation. In 1938, both Hasegawa and Eidman stopped working with seeds because Eidman was transferred and Hasegawa's lab was bombed during the war. That was a great loss. But in 1939, 1940, Dr. Lacan, Georg Lacan, he was born in Greece, but he worked in Hohenheim, Germany. He got this information and he perfected the selenium method developed by Hasegawa, Eidman, and Schmidt. And he developed what he called for the first time the topographical selenium methods. But he realized that the selenium salts were very toxic. And with the help of Kuhn and Jerkel, who used to work on near his lab, they selected several tetrazolium salts and realized that the 2,3,5 triphenyl chloride, which is the salt that we use today, was selected among several tetrazolium salts. After the finish of the Second World War in 1945, Lacan's work was first published in America. And in 1949, the tetrazolium test was incorporated officially by the German seed testing rules. In 1950, Lacan presented his results during another ISTA Congress in Washington, D.C., taking this information to the United States and to America. And then pioneer work with the tetrazolium test started to be developed by the Boyce Thompson Institute, the company Pioneer Hybrid, using the test for corn, and at Iowa State University. In the 50s, substantial achievements were obtained again in Iowa State University by Isley, Bass, Smith, and Thornberry. At the University of Idaho with the work of Dr. Parker. At the University of Hohenheim with Dr. Bullitt and Dr. Steiner's work. And finally, at North Carolina State University with the work performed by Dr. Robert Moore, which together with Dr. Lacan, Dr. Moore and Lacan, I would say, not mentioning that the other researchers did, excellent work, but Dr. Moore and Dr. Lacan were the one who really published a lot of work and developed the methodology of the test for several seed species. In 1956, ISTA founded the Tetrazolium Committee, which I'm glad to be a part of it since 1998. And from 61 to 1970, important developments were achieved again with Dr. Moore at North Carolina State University, at Mississippi State University with Dr. DeLuche and his team, Oregon State Seed Laboratory with the work of Dr. Grabe, and in 1962, The Tetrazolium test for seed viability handbook was published by Mississippi State University, headed by Dr. DeLucia and his team. This handbook was published and translated in Portuguese and published in Brazil as well in 1976. In 1966, based on the work led by Dr. Lacon and Dr. Bullitt, it was incorporated in the ISTA rules, the Chapter 6, named Biochemical Test for Viability, the Topographical Tetrazolium Test, which covered viability procedures for over 90 species. And the use in the 1970, the use of the Tetrazolium test was accepted by AOSA, Association of Official Seed Analysts in the United States, based on the work led by Grape, and they released the Tetrazolium testing handbook, which was also translated and published in Brazil. In 1983, AOSA published the Seed Vigor Testing Handbook, which combined information about the Tetrazolium test, covering vigor procedures for soybean, cotton, corn, and wheat. And a very important achievement was established by ISTA with a work led by Dr. Moore in 1985, with the publication of the ISTA Handbook on TZ testing, covering the methodology for viability for over 650 species. AOSA in the year 2000 published the Tetrazolium testing handbook, which was updated up to 2010, and updated version can be downloaded from AOSA website, but also covering viability procedures. 2003, as part of the Tetrazolium Committee of ISTA, a work led by Dr. Norbert Leist, Stephanie Kramer, and Andrea Jonitz, started publish the ISTA working sheets on Tetrazolium testing, 2 nice volumes covering viability procedures for agricultural, vegetable, horticultural, tree, and shrub seeds. And even now, the Tetrazolium Committee keeps on updating this information. But when we talk specifically for vigor determination, important work was performed by Dr. Moore from 1960 to 70. He started assigning vigor level for the seeds, started with corn and soybeans. Level 1 to 5 were considered viable, and 6 to 8 non-viable. Class 8 was considered dead seed. And the present location and nature of the standing and the physical condition of the embryo structures were used as criteria in these classification schemes. And during 15 years, from 1981 to 1995, the vigor work with Tetrazolium was included in the Handbook of Vigor Test Method, published by ISTA, initially edited by Perry in 81, later updated by Dr. Fiala in 1987, and in 1995 by Hampton and Tecroni, and also by the Seed Vigor Testing Handbook, published by AOSA in 1983. Specifically with soybean seeds, that's the crop that I work most. At our institution, at Embrapa Soybean, the test has been perfected for vigor determination, and we published several handbooks with specific procedures, starting the first one in 1981, then the first version of our handbook about the methods for TZ test for soybean seeds in 1985. Then in 1998, we published the second edition of this handbook in English, Spanish, and Portuguese. That was coincidentally the year that I started joining the Tetrazolium Committee of ISTA. And in 2018, we published the third edition, and now we're finishing the fourth updated edition. And we also carried out intensive trainings of over 96 formal courses on tetrazolium and seed pathology. And we trained over 2,300 people with the procedures for tetrazolium in soybean seeds. Coming back to soybean seeds in Brazil, since we did all this publication and all this training, we can say that every year the test is routinely used by all seed laboratories that run analysis with soybean seeds. And we estimate that yearly over 300,000 analyses are performed per year. But we also carry a lot of work with tetrazolium tests with coffee, tropical forage crops, sunflowers, common bean, corn, wheat, and peanuts. And I have to mention an important work carried out by Dr. Rocky Cravioto and his team in INTA in Argentina. And in 1995 and 2008, they published the methodology of the TTZ test for soybean seeds in Spanish and also in English. And Abratis, the Brazilian Association of Seed Technology, in 1999 published the handbook on seed vigor. And in this handbook, we covered the method for vigor specifically for cotton, peanut, common beans, corn, and soybean seeds. Also, AOSA published in 2009 the Seed Vigor Testing Handbook and special chapters which were edited by myself and Francisco Krizanovski covering viability and vigor on tetrazolium for soybean, corn, common beans, cotton, and peanut seeds. And in 2017, the tetrazolium methods for determining vigor in soybean seeds was included in the seed vigor testing chapter of the ISTA rules, chapter 15. Basically, as a summary of principle of the test, the tetrazolium indirectly determines the respiration of the cells in the seed tissues. And it relies on the activity of 6 different dehydrogenase enzymes, which work at the glycolysis and the Krebs cycle. Actually, it's a reduction reaction. And whenever we place the seeds to be moistened under tetrazolium solution, which is colorless and diffusible, under the action of these dehydrogenase enzymes in the living tissue, the tetrazolium salt is transformed in triphenylformazine, which is red and non-diffusible, presents the typical carmine red color of the tetrazolium reaction. So we have 3 different stain intensities. Normal faint red, it identifies vigorous tissues. Intensive red means deteriorating tissue, and non-stained that usually ends up with white or yellowish is a dead tissue. As seen on this picture, we can see here normal red vigorous tissue, intensive red deteriorating tissue, and white or yellowish tissue, meaning dead tissue. And Abratis, the Brazilian Association of Seed Technology, recently published a new edition of the vigor testing handbook and covering the tetrazolium methodology for vigor and viability for 17 species, such as cotton, peanut, common beans, sunflower, 8 species of tropical forage grasses, corn, soybean, solanaceae, specifically for tomato and bell pepper, and wheat. And I'll be covering briefly some slides, some photos illustrating these methods, beginning with soybean seeds, which we classify in 8 different classes. Classes 1 through 3 are viable and vigorous. 4 and 5 are viable but non-vigorous. 6 and 7 are non-viable, and class 8 are dead seeds. And we also identify by the symptoms of the Tetrazolium staining on the seeds, the different type of problems that can occur with soybean seeds, such as mechanical damage, weathering damage, and damage caused by stink bugs. And on this picture, named as A, we have a perfect seed, very vigorous seed. On B, we have mechanical damage, which is by those intensive red stains. And then on C, we have typical symptoms caused by stink bug damage. And on D, weathering damage, mainly caused by rainfall on pre-harvest. Cotton, we follow the same procedures using 8 classes of vigor level, being class 1 the most vigorous and class 8 the dead seeds, also identifying the typical problems such as mechanical damage, weathering, and damage caused by stink bug. As mentioned, illustrated on figure A, perfect, sound, high vigorous cotton seed. On B, we have with bruises caused by mechanical damage. C, damage caused by stink bug. And D, caused by weathering. On common beans, we follow actually the same procedures as performed on soybeans, 8 classes of vigors, also identifying the major causes of seed problems, such as mechanical damage, weathering, and stink bugs. On figure 8, a perfect stained Phaseolus seeds, common bean seeds. B, with both types of mechanical damage, immediate and bruises. C, typical damage caused by stink bug. And D, weathering damage. Maize seeds, corn, we rely on 3 classes of vigor. Class 1, viable and vigorous. Class 2, viable, non-vigorous, and class 3, non-viable. As illustrated here, on figure A, we have a high vigor corn seed stained with tetrazolium. On B, we can see some white spots on the lower part of the escutellum, transforming that seed in a medium vigor. On C, we have a low vigor seed with a mechanical damage on the upper part of the scutellum. And on D, we have a non-viable seed, which caused by mechanical damage that ruin entirely the embryonic axis of this fruit seed. Wheat seeds, we use 4 different vigor levels. Class 1, viable, vigorous. 2, viable, non-vigorous. 3, non-viable. And 4, dead seed. As illustrated here, on A, we have a perfect, sound, high vigorous wheat seed. On B, we have some medium type vigor seeds because of mechanical damage in the lower part of the scutellum. On C, we have a non-vigorous seed because of occurrence of severe mechanical damage. And D, we have no stain, meaning that's a dead seed. Sunflower, we use 5 different classes. Class 1, high vigorous seed. Class 2, medium. Class 3, low vigorous seeds. Class 4, non-viable. And class 5, dead seed. As illustrated here, on A, a perfect, sound, high vigorous seed. B, some mechanical damage on the upper part of the cotyledon, making it medium vigor seeds. On C, intensive red mechanical damage on the tip of the radicle, making these seeds low vigor viable seeds. And on D, several spots of mechanical damage all over the seeds, making it non-viable. Peanut seeds, 3 classes. Class 1, viable, vigorous. Class 2, viable, non-vigorous. And class 3, non-viable seeds. As illustrated here, on A, we have a peanut seed stained with tetrazolium with a severe crack, mechanical damage. On B, a bruise caused by mechanical damage. C, typical stink bug damage. And D, weathering damage, making these seeds on D non-viable. Solanaceae, specifically for tomato and bell pepper, we use 3 classes: class 1 viable and vigorous, 2 viable non-vigorous, and 3 non-viable. As illustrated here for tomato, on A, a perfect sound high vigorous seed. On B, we have a viable non-vigorous seed. C, non-viable seed, and D, completely white, non-stained dead seed. And for forage, we have, as I mentioned, 8 different species. I'm going to be illustrating for Brachiaria, renamed Urucloa, but this is also true for Andropogon, Cynodon, Malinis, Panicum, Paspalum, Penicetum, and Setaria, using 3 different classes: class 1 viable vigorous, 2 viable non-vigorous, and 3 non-viable. As illustrated here, for this Urucloa, A, sound embryo, perfectly stand high vigorous seed. On B, we have a viable non-vigorous seed. On C, non-viable seed. And on D, dead non-viable seed. And my final comments would be wrapping up whatever I mentioned here, that the use of the tetrazolium results, as with any vigor test, can assist the categorization of vigor levels for different seed lots and for estimating performance of these lots in the field under optimum and stressful conditions. We've done several work on these lines, especially for soybean seeds. And also that the methods of the test has been perfected for determining not only viability, but also vigor of several seed species. However, due to dynamism of this test, its methods will keep on being developed and perfected for different species. It's also important to determine on referee tests the accuracy and precision of the method that should be conducted to verify how well the interpretation of the test results are being performed. And finally, and additionally, with the improvement of techniques of computerized image analysis, effort should be dedicated to develop softwares for reading and estimating seed viability and vigor by digital means. So I want to thank you very much. And I will be open here for discussions and questions.
Thank you very much as well. There are a number of questions coming in. That's why I was a little late in opening my camera. I was trying to answer a few of them. Generally, I can tell you there was a few questions. The whole session can be reviewed again on the ISTA YouTube channel. The next days it will be available, and you may be able to subscribe to the YouTube channel and get information when there are new videos coming out. Now I need to make my thing a little bit bigger here that I can read it properly to you. And we try to stick to the time, but it's quite a number of questions coming in, and we would like to start with is the Tetrazolium applicable to all species of seed species? I'm making special reference to hard seed, so like okra or Utemello. Otherwise, which methods are best suited for these tests to have a viability test of this species?
Yes, you can do for any seed species. If you have a seed, you can do it. Especially, you mentioned hard-seeded species such as okra. In fact, my master thesis, I worked with hard-seeded soybeans. Well, since the hard-seeded are impermeable to water, first thing we have to do before running the procedures for imbibing the seeds will be to overcome this type of dormancy, usually with a sandpaper or with a puncture. I prefer using a sandpaper instead of a puncture. So we will be scarifying the surface of the seeds. Then we'll be pre-imbibing the seeds to reactivate the respiratory system, and then going to the staining procedures. If you go to ISTA rules, we have the procedures, if I'm not mistaken, for okra seeds. You can find it there. Or going back to the handbook published and edited by Dr. Moore in 1985, I'm sure that among the 650 species, you'll find okra there. So for sure, you can do it.
Yes, and that's another point which I would generally refer to. There are a few questions coming in. Is it ISTA approved? You can have a look at the ISTA rules. You can get the chapters via the ISTA website. If you need them, there's a special chapter on this topic, so you can buy them. But we can answer a few questions here probably as well. What about sunflower? Is that on? Do you know that, Jose? If that's on the ISTA
Yeah,
rules?
sunflower. Yes, I mentioned that in the Brazilian publication, the handbook, we have the procedures for viability and also for vigor. And depending on the variety that or the line that you were working with sunflowers, you may have some seeds that will not germinate because of dormancy. It's not a hard-seeded type, but is embryo dormancy type. But the other advantage of the Tetrazolium test is that you can run the viability and the vigor test if you have the procedure, even under dormant seeds. And you can use it in sunflower. As I mentioned, several tropical grasses have dormancy, and usually, like Urucloa, the germination test procedure would take up to 28 days. So you can speed up for determining viability using the Tetrazolium test, which is officially accepted for the international market of export and import of Urucloa seeds, officially adopted by ISTA for all laboratories that export and import Urucloa seeds. You can run the Tetrazolium test, which is considered an official method for determining viability.
And how many seeds do need to be tested for this viability test? How many seeds do you need?
Yes, if it is for an internal control system in your laboratory of a seed company, you can use from 100 to 200 seeds. Usually we run with subsamples of 50 seeds each. But if it's for issuing an official bulletin, you have to follow the procedures of the rules. And you have to go from 200 to 400 seeds using subsamples of 50 seeds each. So either 4 subsamples of 50 seeds or up to 8 subsamples of 50 seeds.
Right. There are a lot of questions coming in, and I need to be looking what will be the easiest. Of course, there are also thank yous coming in for the good presentation.
Thank you.
There's an interesting question. It looks like the analysis is a bit subjective, which you might not 100% agree. Could the analysis become more quantitative, maybe using imaging technology?
Yes, that's what we're trying. I've been working on that for over 10 years, but so far we did not get some software that can be commercially used. But that's correct. We are trying. We kind of overcame this limitation of having the influence of the analysts analyzing, for instance, for soybeans in our handbook. We have over 210 different schemes that in case of doubt, the analyst will go to that handbook and with those schemes, and those schemes came from class 1 to class 2, 3, 4, and 5, which are viable, and then class 6 and 7, which are non-viable, and class 8, which is dead. And together with the training, in fact, during this week, we restarted with the 72nd Tetrazolium and seed pathology testing in Embrapa soybean. After the pandemic issue, is the first training course that we have 37 people from all over Brazil being trained hands-on in our lab. So it started yesterday and will end this coming Friday.
Good, thank you very much. I got a number of questions which I would like to answer generally as something there which you mentioned as well. There are Tetrazolium handbooks available, and you can learn more about the techniques. And there, if there is the need for Tetrazolium workshops, this can be done as well. It can be asked to the Tetrazolium committee, by laboratories or by interested parties to organize that. That is probably something you can approach ISTA with, and that is very important. We are starting to have physical workshops again, and I think for this type of work, as you need to really touch and do, it is very important to have a physical workshop to see the seed, really to be able to see if it's viable or not. That can be done. And if you subscribe to the ISTA newsletter, you will get information, or the social media channels, you will get information where these type of workshops take place and may take place in your area. There are really too many questions now, which we cannot all answer. Thank you very much. Some are about maybe they can get your PowerPoint and have it, but they need to approach you to get this. We will not distribute it, and there's also no distribution of participation certificates, as this is only a webinar and not a training session.
Yeah, my presentation, I can, if anyone that is listening would like to have, please contact me directly or through ISSS or ISTA, and I'll be glad to share with you.
Yep, thank you very much. And I would like to close this this session, mentioning again that everything will be available on the ISTA YouTube channel, and you can listen to it again. That will be quicker than even getting the presentation probably shipped. And also like to mention from our side again that there is the 14th biennial ISSS conference coming up on challenges of seed science in a changing world, and that is from 3 to 7 of July. We mentioned that at the beginning of this before, in Paris at the Sorbonne University, and in November, from 2 to 4 November in Athens, there will be the ISTA Seed Symposium on quality seed for sustainable agriculture, where the deadline for submission of papers is August 1, and application deadline for funding under the Young at ISTA funding project until 5 of September. I thank all of you, and we saw that Duarte was gone before, so He excused himself. He is a young father and need to pick up his kid from kindergarten, which is probably very important. We don't want to leave young kids outside the kindergarten alone. So Jose, I'm looking forward to see you again in Brazil in September at the Apparatus Congress, where we can also announce that that is taking place in the second week of September in Curitiba. So who's interested from that area could join us there. And I thank everybody present. And when the top, we had nearly 250 attendees listening. That is very much. Thanks again for the good presentations, and have a good evening or good day, or wherever you are in the world, a good night. Thank you very much. Take care. Bye-bye.
Thank you. Bye-bye. See you. Bye-bye. Thanks a lot.